Imagine you're spinning through space at over 500,000 miles per hour, yet you feel perfectly still. You're a passenger on a starship called Earth, orbiting within a galaxy so vast that even traveling at light speed, it would take you 100,000 years to cross from edge to edge. This is the Milky Way, our home containing over 400 billion stars, each potentially hosting worlds we'll never see. We've never stepped outside to witness its full spiral arms unfurling through space. Tonight, we'll journey to the boundaries of our galactic neighborhood. We'll discover that everything you thought you knew about size, distance, and your place among the stars is merely the opening chapter of an infinite story. What secrets hide in the Milky Way's spiral arms, and what lies beyond the invisible edges where our home fades into the cosmic dark. If you find comfort in this kind of journey, please consider liking, subscribing, and leaving a comment telling us where you are listening from tonight. Settle in. Dim the lights. Make yourself comfortable as we drift together through starlight and silence to explore the magnificent scale of our galactic home. Let the journey begin. Step outside on a quiet night. The air is still. The stars are beginning to reveal themselves as the last traces of twilight fade. Above you stretches a dome of darkness, sprinkled with light. For most of human history, this view was the entire universe. The sky felt eternal, infinite, unchanging. And standing there in your backyard, you can feel the same illusion. The world beneath your feet seems vast. Your house, your street, your town. These things occupy your entire reality. Traveling across a city might take hours. Driving across your country could take days. Crossing an ocean might take weeks. To us, Earth feels impossibly large because we experience it step by step, road by road, mile by mile. But scale has a way of humbling us when we change perspective. Lift yourself gently upward, like a balloon drifting into the sky. At first, the view is still familiar. Buildings, roads, rivers, all laid out in patterns, but keep rising. Soon, entire neighborhoods blur together. The landmarks that guided your daily life vanish into a patchwork of color. At 100 miles up, where the International Space Station orbits, you can no longer see houses or even cities. What once felt endless, the place you grew up, the places you've traveled, has dissolved into a single glowing sphere. At this height, the world is fragile. Clouds swirl in white spirals stretching across continents. Oceans gleam a deep blue, wrapping around the globe like liquid glass. The land below appears not as a collection of nations and borders, but as a single continuous surface. From orbit, wars and histories, languages and cultures all collapse into a thin, delicate shell. Everything you know, everything you've ever experienced, is compressed into a single shimmering marble floating in the darkness. Now rise farther still. Leave Earth behind entirely. From the distance of the Moon, 240,000 miles away, Earth is a blue jewel suspended in black. It fits comfortably between your outstretched fingers. All of human civilization, every memory, every achievement, shrinks into that tiny dot of light. From Mars, Earth becomes smaller still, just a star among many. From the outer planets, it all but disappears. This is the lesson of perspective. What feels infinite from the ground is finite from above. What feels monumental up close becomes microscopic at a distance. And this perspective keeps shifting as we zoom farther out. Step back again, past the sun, past the solar system. At this scale, Earth no longer registers as anything at all. Even our entire planetary family, the Sun, with its entourage of worlds, shrinks to a single point of light, lost among the billions scattered across the galaxy. The stars you see overhead are not close together, though they may appear that way. Each one is a blazing nuclear furnace separated by oceans of emptiness. Together they form the great structure we call the Milky Way. But from our backyard view, the galaxy appears only as a faint, hazy river stretching across the night. Few things are more humbling than realizing that what looks like a gentle band of light is, in fact an island of 400 billion stars. From backyard to galaxy, scale transforms our understanding. The familiar shrinks, the unimaginable grows. The Earth is not infinite. The solar system is not vast. The galaxy itself, though incomprehensibly large, may be just one island in a sea of billions more. And yet, this shrinking is not a loss, it is a revelation. It tells us that while our lives unfold on a small world, we belong to something grander, something wider, something almost infinite. Every time you look up from your backyard, you are not only standing on the Earth, you are standing inside the Milky Way. And that changes everything. Imagine yourself floating just 250 miles above Earth, the height where the International Space Station orbits. At this altitude, astronauts describe an almost dreamlike sensation. They peer down through a tiny spacecraft window, eager to spot familiar landmarks. Perhaps they hope to see their hometown, or the curve of a coastline they once walked along, or even the street where their childhood home still stands. But as their eyes adjust, something strange happens. The familiar details vanish. Cities that once seemed endless from the ground dissolve into faint smudges of light. Roads become invisible, fading into shadows beneath clouds. Entire neighborhoods shrink beyond recognition. And then comes the realization. No matter how carefully they search, no astronaut has ever seen their own house from space. Distance erases detail. This vanishing act continues the higher you climb. At 1,000 miles above Earth, states and provinces blur together into abstract shapes. At 10,000 miles, continents become indistinct, their outlines melting into shades of blue, green, and tan. At 25,000 miles, Earth becomes a sphere glowing in the black of space. Storms swirl across entire oceans, weather systems stretch across hemispheres. Yet every human being who has ever lived exists on that tiny marble. What seemed infinite from the ground now fits neatly inside a single glance. The entire history of humanity, the empires, the revolutions, the wars and the art, the discoveries and the dreams, all compressed into a fragile ball of water and rock. From this height, there are no borders, no lines dividing nations, just a delicate, swirling world. Pulling back even farther, the Earth begins to fade into insignificance. From the Moon, our planet glows like a jewel in the distance. From Mars, it is no more than a star, indistinguishable from the countless others that shine across the night. By the time you reach the outer planets, Earth is invisible to the naked eye. Our home disappears entirely into the background of the cosmos. This vanishing is not failure. It is revelation. It teaches us something profound about perspective. Up close, our lives feel monumental. Entire cities seem immense. Nations appear as though they could never be ignored. But step back even a little, and the details collapse. Human struggles, human triumphs, even human existence itself. All of it shrinks into something so small that it cannot be seen from the very next planet over. And yet, this perspective is not meant to diminish us. Instead, it reminds us that we are part of something larger. Earth disappears because the scale of the galaxy overwhelms it. The Milky Way contains hundreds of billions of stars, each separated by distances so vast that even our planet, with its oceans and mountains, its forests and deserts, vanishes into nothingness. Imagine standing on a mountaintop and looking across the horizon. The closer ridges are detailed, you can see trees, rocks, streams, but the distant peaks appear hazy, their features lost in the distance. Now multiply that effect by 1,000, 1,000,000, 1,000,000,000. That is what happens when we try to see Earth in its galactic context. We are simply too small. The vanishing Earth teaches us the first rule of cosmic perspective. The farther back you go, the less detail survives. What we consider enormous shrinks into invisibility. What we thought was permanent reveals itself as fragile. And beyond every disappearance, a greater reality waits to be seen. Take a marble into your hand. Hold it between your fingers. Feel its tiny weight. Imagine, just for a moment, that this marble is Earth. Every ocean, every continent, every city, every person compressed into a smooth sphere no larger than your thumbnail. Now imagine where the nearest star would be in this scale model. Perhaps you place another marble across the room or on the far side of the house. But no. On this scale, the nearest star, Proxima Centauri, would be over 4,000 miles away, the width of an entire continent. A single marble, floating alone, with nothing else nearby except another marble placed thousands of miles down the road. That is the reality of interstellar space. The stars may appear close together when you gaze at the night sky, their light twinkling side by side. But in truth, they are separated by staggering gulfs of emptiness. Oceans of darkness so vast that light itself, the fastest thing in existence, takes years to cross even the smallest gap. Consider this. If you could drive to the nearest star at highway speed without ever stopping, it would take more than 40 million years. 40 million years of continuous travel just to move from one marble to the next. Our ancestors who painted caves with flickering torches lived only tens of thousands of years ago. Entire species have risen and vanished in less time than it would take to make that drive. And yet, there are not just a few stars. There are hundreds of billions of them, every one a blazing sun, many larger and brighter than our own, some with families of planets orbiting them, some with worlds that might even resemble Earth, all of them scattered like isolated islands across an ocean of night. This is the true scale of the Milky Way. Stars are not clustered tightly together. They are not crowded. They are scattered so thinly that even when we shrink Earth to a marble, the nearest star is still continents away. Think again about that marble you hold. Now imagine the Sun as a beach ball resting half a mile away. Jupiter would be a large marble 3 miles beyond. Saturn would be farther still, 6 miles down the road. Pluto would be 30 miles away, barely visible. And then, the next star 125,000 miles in the distance. A separation so enormous that it defies every instinct we have about space and closeness. The marble and the star exercise reveals the emptiness that defines our galaxy. It shows us that the Milky Way is not a crowded city of stars, but a sparse wilderness. It reminds us that our solar system, so full of worlds and moons, is only a small pocket of activity in a much larger void. Holding that marble, you are holding not just a planet, but a perspective. Earth is both infinitely precious and impossibly small. The nearest star may be unimaginably far away, but together these isolated marbles create the glowing river of light we call the Milky Way. And somewhere in that river we float one marble among hundreds of billions, spinning in the darkness. When we imagine space, we imagine stars, bright suns shining against the black. We imagine planets, moons, glowing nebulas, and galaxies spiraling like pinwheels. But most of the universe is not light. It is darkness. Between the stars stretches a vacuum so complete that it humbles even our most advanced technology. In a cubic inch of interstellar space, you may find a single atom. Compare this to the air you breathe right now, which contains trillions upon trillions of atoms in the same volume. The gap between stars is not just empty, it is emptier than almost anything else in existence. And yet, this sea of nothingness is what defines our galaxy. The Milky Way is not primarily stars, nor planets, nor dust. It is vast, yawning emptiness. The stars are islands scattered across an endless ocean of black. The planets are shores that rise briefly from the waves, tiny places of matter and light, surrounded by infinite silence. Consider Voyager 1, the spacecraft launched in 1977. It has travelled farther than any human-made object, speeding away from the Sun at nearly 38,000 miles per hour. For decades it has drifted through space, crossing billions of miles, and yet, in all that distance, it has not encountered a single solid object. No rocks, no dust clouds dense enough to notice. It is adrift in an emptiness so complete that it may wander for millions of years without brushing against another speck of matter. But emptiness does not mean absence. The void between the stars is filled with invisible forces. Magnetic fields thread through it, shaping the motion of charged particles. Wisps of hydrogen and helium, left over from the Big Bang, flow like ghostly rivers, moving from one part of the galaxy to another. Dark matter, unseen and mysterious, forms a vast halo that envelopes everything, holding the Milky Way together with gravity we cannot see. To our eyes, it is black. To our instruments, it is silence. But this ocean is alive with invisible currents, unseen tides, and hidden depths. If you could drift in the middle of this void, between stars, the darkness would be almost complete. No sun would warm your skin, no planet would offer a horizon. The nearest star would be a faint point of light, its warmth and brilliance lost across the years it took for its photons to reach you. And yet, from this emptiness, the beauty of the galaxy emerges. The darkness gives meaning to the stars. The silence gives contrast to the bursts of light. Without the void, the Milky Way would not exist as we know it. The sea of darkness is not something to fear. It is something to marvel at. It is the canvas upon which every story of creation is painted. It is the stage on which stars ignite, worlds form, and life emerges. It is the silent partner to light, a presence as necessary as the suns themselves. The Milky Way is a galaxy of stars, yes. But more than that, it is a galaxy of darkness, a sea of night, stretching forever, within which every island of light is born, shines, and eventually fades. As you sit here, listening, you feel still. The floor beneath you does not shake. The air around you feels calm, but in truth, you are moving faster than you have ever imagined. The Earth itself spins at about 1,000 miles per hour at the equator, carrying you eastward. On top of this, the Earth orbits the Sun at 67,000 miles per hour, dragging you around the star once every year. These motions are staggering by human standards, but they are just the beginning. Because the Sun itself, along with all its planets, moons, asteroids, and comets, is racing around the center of the Milky Way at over 560,000 miles per hour, 500,000 miles every hour. Faster than any spacecraft, faster than any machine, faster than anything humans have ever built, and yet you feel nothing. The ride is so smooth, so constant, that it passes unnoticed. This is our galactic carousel. Our entire solar system is bound by the gravity of the Milky Way's core. Like a stone on a string, we orbit around the center, a point 26,000 light-years away. One full lap takes 230 million years. Pause with that number. 230 million years. The last time Earth was in this exact spot, the continents were fused into a single landmass called Pangaea. Dinosaurs had not yet evolved. The most complex creatures on land were small reptilian ancestors of mammals. Oceans teemed with early life, but humanity was not even a dream. Since the birth of Earth 4.5 billion years ago, our solar system has completed only about 20 laps around the galaxy. Our planet is 20 galactic years old, and during that time, life has appeared, evolved, flourished, and transformed the surface of our world. Every plant, every animal, every civilization has emerged during the briefest slices of these immense orbits. All of human history, from the first stone tools to the building of cities, from the rise of Rome to the launch of spacecraft, has unfolded during less than 1% of a single galactic year. Civilizations have risen and fallen without moving more than the tiniest fraction along this carousel's path. And yet, this motion shapes everything. As our solar system rides its orbit, it drifts through spiral arms where star formation is more active. It passes through regions of higher radiation or quieter interarm spaces. Some scientists even wonder if mass extinctions on Earth may be linked to these passages. Periods when our world crosses denser regions of the galaxy, encountering more comets or cosmic radiation. Right now, we are in one of the calmer suburbs of the Milky Way, a relatively safe neighborhood between arms. Perhaps that is why life has thrived. Perhaps our very existence depends on the timing of this vast orbital ride. The galactic carousel turns slowly, endlessly, silently. We are passengers on a journey so immense that it takes hundreds of millions of years just to make a single lap. Look around you. Everything you see, everything you know is in motion. Together we spin, orbit, and race across the galaxy, forever riding the carousel of the Milky Way. Think of a year as you know it. 365 days, marked by the turning of the Earth around the Sun. This rhythm feels absolute. Our lives are organized by it. But the solar system itself is also orbiting, not around the Sun, but around the center of the Milky Way. This much larger journey defines what astronomers call a galactic year. One galactic year is not measured in months or days. It is measured in millions. To complete one lap around the galaxy's center takes about 230 million Earth years. Pause for a moment and let that number expand in your imagination. 230 million years. That is nearly 1,000 times longer than the time humans have walked upright on Earth. Now, consider where we were during our last lap. The last time Earth occupied this exact point in the Milky Way's orbit, dinosaurs had not yet appeared. The great reptiles that later thundered across the continents were still tens of millions of years away. Pangaea, the ancient supercontinent, was still fused together. Mammals existed only as tiny, shrew-like creatures hiding in shadows. Since then, the Earth has travelled once around the galaxy, and in that time, entire species have appeared and vanished. Dinosaurs rose to dominate the planet, then fell to extinction. Mammals flourished, primates evolved, and eventually humans arrived. All of this, every step of our evolution, unfolded within the space of a single galactic orbit. Our world is about 20 galactic years old. That means in its 4.5 billion year history, Earth has circled the galaxy just 20 times. Imagine a clock whose hand ticks once every 230 million years. 20 ticks of that cosmic clock, and all of Earth's history has passed. Humans? We have lived for less than 1% of a single tick. All of recorded civilization, from ancient Mesopotamia to today, is a blink on the face of this clock. Entire empires rose and fell without Earth even shifting noticeably along its orbit around the Milky Way. This perspective can feel overwhelming. But it also offers comfort. It shows us that change is constant. Civilizations may seem monumental in the moment, but they are whispers compared to the rhythm of the galaxy. Our struggles and triumphs are real, but they exist within a larger story that spans billions of years. A galactic year is not something we will ever experience fully. No species ever has. And yet, by measuring it, by naming it, by recognizing our place within it, we gain a kind of perspective that grounds us. We see that we are passengers on a ride far grander than anything we could build ourselves. The Earth spins, the Earth orbits the Sun, and the Sun orbits the Milky Way. Each motion is a wheel within a wheel, each carrying us through the passage of time. And while our individual lives are brief, we share in this cosmic journey. Every breath you take happens while travelling thousands of miles through the galaxy. Every moment is part of the lap we are taking around the Milky Way's core. Dinosaurs walked the Earth the last time we were here. What life will walk here when Earth completes its next orbit? That is the mystery of the galactic year, a reminder of the immensity of time and the small but wondrous part we play in it. For much of human history, we believed the universe revolved around us. The Earth seemed fixed at the centre, with the Sun, the Moon, and the stars circling overhead. It was a comforting picture, one that placed humanity in the middle of everything. But when astronomers peered deeper, they found that this picture was wrong. Earth was not the centre, the Sun was not the centre, even our solar system itself is not central. Instead, we live far from the heart of the Milky Way, tucked away in a spiral arm, about 26,000 light-years from the galactic core. If the galaxy were a great city, the centre would be a bustling downtown, crowded with skyscrapers of stars and heavy with cosmic energy. By contrast, our solar system is more like a quiet suburb. We live in the galactic outskirts, in a place that is less chaotic, less dangerous, but also less dramatic. This distance from the centre is one of the reasons life may have flourished here. The core of the Milky Way is a tumultuous region. Stars there are crammed together 1,000 times more densely than in our neighbourhood. Supernovae erupt more often, giant clouds of radiation fill the space, and anchoring it all is a supermassive black hole, Sagittarius A, whose gravity stirs the heart of the galaxy. Had our solar system been born there, the odds of life surviving might have been slim. Too much radiation, too many close encounters with wandering stars, too much chaos for planets like Earth to hold on to stable orbits. Our quiet corner of the galaxy has been, in a sense, a safe harbor. And yet, the forgotten center remains the true anchor. It is what holds us here, orbiting silently. Even from 26,000 light-years away, its gravity keeps the entire galaxy bound together. Its black hole heart, hidden behind dust and clouds, is the invisible hand guiding our cosmic carousel. We may not see it directly with our eyes. Dust obscures our view in visible light. But astronomers, using radio waves and infrared telescopes, have pierced that veil. They have watched stars whipping around an unseen point, moving so fast that only a black hole millions of times more massive than the Sun could explain their motion. This invisible giant is the Milky Way's true center. Knowing this changes our perspective. Earth is not central. Humanity is not central. Even the Sun is not special in its position. We orbit quietly, far from the core, part of a spiral arm among hundreds of billions of other stars. And yet, there is beauty in this humility. The forgotten center does not diminish us, it gives us context. It reminds us that we are part of something vaster than imagination. We are not the hub of the galaxy, but we are connected to it, bound by its gravity, drawn into its rhythm. We are suburban dwellers in a cosmic city. The heart of the Milky Way may beat far away, but every step we take, every star we see, every breath we breathe is tied to it. The forgotten center is our anchor, even if we live in the quiet neighborhoods at its edge. At the very center of the Milky Way, hidden behind dense clouds of dust and gas, lies something extraordinary. An object so powerful, so massive, that it warps both space and time. Sagittarius A, a supermassive black hole with the mass of 4 million suns compressed into a single point. We cannot see it directly. Black holes do not emit light, but we know it is there because of the way stars behave around it. Imagine watching a group of fireflies circling an invisible predator in the dark. You cannot see the predator itself, but you know it must be there because of the frantic, looping paths of the fireflies. Astronomers have seen stars racing around Sagittarius A at thousands of miles per second, their orbits betraying the presence of the unseen monster in the center. This black hole is not just an exotic curiosity. It is the anchor of the entire Milky Way. Its immense gravity helps hold the galaxy together, shaping the orbits of stars across tens of thousands of light-years. Without it, the Milky Way as we know it might not exist. Black holes are strange beyond comprehension. At their heart lies a singularity, a point where matter is crushed to infinite density. Surrounding it is the event horizon, the boundary beyond which nothing, not even light, can escape. Step too close, and you are gone forever, drawn into the abyss. And yet, paradoxically, Sagittarius A is quiet compared to some black holes. In distant galaxies, we see their central black holes consuming matter with ferocious hunger, blasting jets of radiation across millions of light-years. Ours, by contrast, is calm. It slumbers. Occasionally it flares with activity when gas or dust falls too close, but for the most part, it waits silently at the core. It is strange to think that everything we know orbits something so alien, that the stars of our night sky, the sun that warms us, the earth beneath our feet, all of it is bound by an invisible presence 26,000 light-years away. We circle it endlessly, passengers in a dance we cannot feel. There is poetry in this. A galaxy is not simply a whirl of stars. It is a system held together by unseen gravity, by forces beyond vision. And at its center lies an object that challenges our very understanding of physics. For humans, the black hole at the heart of the Milky Way is both terrifying and humbling. Terrifying because it represents destruction so absolute that nothing can return once it passes the horizon. Humbling because it reminds us that the universe is not built for us. It is built on laws far deeper, far stranger, far more mysterious. And yet, without this monster at the core, we would not be here. Its gravity is what binds the galaxy into its spiral shape. Its presence is what keeps our sun and all its planets on their vast orbit. The black hole's hunger shaped the Milky Way, and in a roundabout way, it shaped us too. When you look up at the stars tonight, remember this. Every one of them, including the sun, is in motion around a silent, invisible heart. A heart that beats in gravity, not light. A heart that defines the very existence of our galaxy. Sagittarius A, the black hole at the center of it all. If we lived outside the Milky Way, we could see it clearly. A vast spiral of stars stretching across the void, glowing with the light of hundreds of billions of suns. But we live inside it. Like a person trying to describe their house without ever stepping outside, we must imagine its shape from within. This is no easy task. Dust clouds block our view in visible light. From Earth, the Milky Way appears as a hazy band across the sky, but its true form is hidden. So astronomers have learned to map it indirectly, using clever techniques to measure what we cannot see. One method relies on standard candles, stars whose brightness we know. Cepheid variables, for instance, pulse rhythmically. The speed of their pulsation reveals their true luminosity. By comparing how bright they appear to us versus how bright we know they are, astronomers can calculate their distance. Like lighthouses flashing across the galaxy, they mark the spiral arms and the scale of the Milky Way. Globular clusters, ancient swarms of stars orbiting the galaxy, also provide clues. By charting their positions and motions, scientists outline the Milky Way's halo and measure its center. These clusters are like distant satellites, tracing the gravitational well of our home. Radio astronomy adds another layer. Clouds of hydrogen gas emit faint radio waves that pass through dust. By mapping these signals, astronomers trace the spiral arms. Each arm reveals itself not through sight, but through invisible whispers picked up by radio dishes on Earth. Even the orbits of stars near Sagittarius A, the black hole at the center, help us measure its mass and confirm our distance from the core. The faster a star whips around that hidden point, the more clearly we see the invisible hand of gravity at work. Piece by piece, observation by observation, the picture emerges, a barred spiral galaxy, about 100,000 light-years across, with a central bar, several major spiral arms, and countless smaller branches. We cannot step back to see it directly, but we know it is there through evidence as solid as the ground beneath our feet. There is a strange beauty in this. We are inhabitants of a structure so vast we cannot see its entirety, yet we are clever enough to map it anyway. Like blindfolded explorers piecing together a mountain range from the echo of our footsteps, we reconstruct the Milky Way from fragments. And in doing so, we realize something profound. Our galaxy is not a single object, but a community. Stars, gas, dust, dark matter, all moving together under the influence of gravity. A living system, invisible to our eyes yet mapped with our minds. Mapping the invisible reminds us of the limits of perspective. From Earth, the Milky Way is just a faint stripe across the sky. But with patience and imagination, we discover that we are part of a grand spiral, one among billions in the universe. We cannot see it directly, but we know it surrounds us. And sometimes, knowledge is more powerful than sight. How large is the Milky Way? The numbers are almost impossible to grasp. From edge to edge, the luminous disk stretches about 100,000 light-years across. What does that mean? Imagine light itself, the fastest thing in existence. In 1 second, a beam of light can circle the Earth 7 times. In 1 year, it can travel nearly 6 trillion miles. Yet even at that speed, crossing the galaxy would take 100,000 years. 100 millennia of constant motion, racing at light speed, just to move from one side to the other. To put this in perspective, modern humans have existed for roughly 300,000 years. Our entire species could have walked alongside a single photon. watching it traverse the galaxy and still not see it reach the other side. Civilizations would rise and fall, languages would be born and forgotten, continents would shift, and still, the light would be traveling. And this is only the visible disk. Surrounding the Milky Way is an even larger halo of stars and dark matter, extending perhaps 10 times farther. The galaxy is not a flat coin but a vast structure, layered and complex, with an invisible sphere of gravity and matter enveloping everything we see. The disk itself is not uniform. Its thickness varies, rippling like a warped record. Some parts are crowded with stars, others are sparse. Spiral arms wind outward from the core, tracing patterns like frozen whirlpools. Each arm stretches for tens of thousands of light years, filled with star-forming clouds and clusters. When you gaze at the Milky Way on a dark night, that glowing river overhead is not the whole galaxy. It is just the inside view of a single spiral arm, seen edge-on. The true scale is hidden, too large for any human eye to grasp at once. Consider the Sun's position. We sit about halfway between the center and the edge, orbiting gently in the Orion Arm. From here, the galaxy stretches outward in both directions, 50,000 light-years to the core and another 50,000 to the outer rim. Even the light from nearby stars takes years to reach us. The farthest reaches of our galaxy are tens of thousands of years away, their photons only now arriving from events that happened before humans learned to farm. And yet, despite its size, the Milky Way is not extraordinary. Many galaxies are larger. Andromeda, our nearest large neighbor, is twice as wide. Giant elliptical galaxies can be 10 times larger still. In the cosmic ocean, the Milky Way is a mid-sized island, impressive to us but modest in comparison. Still, for those of us who live inside it, the scale is breathtaking. To say the Milky Way is 100,000 light-years wide is to say it is nearly infinite to human experience. No ship we build, no probe we launch, could ever hope to cross it. The distances are too great, the timescales too long. And so we look instead. We measure, we imagine, we map its arms and trace its stars. We marvel at the immensity, knowing that we are passengers inside a structure so vast that even light itself requires 100 millennia to explore. The Milky Way is not just big, it is almost beyond comprehension. Our solar system does not float alone in the galaxy. It resides in a neighborhood, a structure that astronomers call the Orion Arm, or sometimes the local arm. Imagine the Milky Way as a colossal hurricane, its spiral arms stretching outward like vast storm bands. We live not in one of the largest arms, but in a smaller spur, a side street branching off the main highways of stars. At first, scientists thought the Orion Arm was little more than a minor bridge, connecting the grander Sagittarius and Perseus arms. But recent observations have revealed that it is far more substantial, stretching tens of thousands of light-years across. It is not a mere spur, but a recognizable feature in its own right, home to some of the most familiar sights in our night sky. When you look at the constellation Orion in winter, with its bright belt of stars and the glowing Orion Nebula, you are seeing the heart of our local arm. When you look at Cygnus soaring overhead in summer, or Perseus shining in autumn, you are still gazing at stars bound within the Orion Arm. This is our neighborhood. It is a fortunate neighborhood. Compared to the galactic center, it is relatively quiet. Star formation here is steady but not overwhelming. Supernovae erupt, but not so frequently that they sterilize entire regions. This balance may have given Earth the stability it needed for life to develop. The Orion Arm is also home to rich star-forming regions. The Orion Molecular Cloud, the Rosette Nebula, and countless other nurseries fill it with activity. Stars are born here, live their lives, and eventually die in brilliant explosions. Some of those explosions enriched the gas clouds that later formed our Sun, and the heavy elements that became Earth, and the atoms in our very bodies. From our perspective, the Orion Arm is vast, beyond comprehension. But from the galaxy's perspective, it is a small branch. The Milky Way's larger arms stretch farther, host denser clusters, and blaze with more luminous stars. Yet this modest arm is our home, the place where the sun and earth reside, where humanity took its first steps, where our entire history has unfolded. There is beauty in this ordinariness. We are not at the galactic centre, not in the most dramatic arm, not near the largest stars. We live in a quiet suburb, surrounded by enough chaos to give us metals and planets, but not so much that life could not survive. Our place is neither central nor extreme. It is balanced, ordinary, and perhaps uniquely suited for us. The Orion Arm is our cosmic neighbourhood, a side street in a galactic city glowing with billions of stars. And as small as it may seem compared to the Milky Way as a whole, it is still a realm of unimaginable scale. Tens of thousands of light-years stretch through it. Its clouds dwarf solar systems. Its stars number in the billions. It is our corner of the galaxy, and it is where our story begins. When you look at an image of a spiral galaxy, you see elegant arms curling outward like the petals of a cosmic flower. It is natural to imagine these arms as solid structures, streams of stars locked together, sweeping through space. But the truth is stranger and more dynamic. The spiral arms of a galaxy are not permanent features. They are patterns. They are density waves, moving ripples where matter piles up temporarily, then moves on. The analogy astronomers often use is traffic on a highway. Cars move in and out, but the traffic jam itself seems to persist in one location. Spiral arms are like cosmic traffic jams, regions where stars and gas are temporarily crowded together, glowing more brightly than the emptier spaces between them. When a gas cloud drifts into a spiral arm, it experiences a kind of compression. Gravity and density squeeze it, encouraging the collapse that leads to star formation. New stars flare to life, their energy illuminating the surrounding gas. Young, massive stars burn so brightly that they light up entire regions, tracing the arm with luminous blue-white points. But these stars live short lives. They explode after only a few million years, often before they even drift out of the spiral arm. The Sun, however, is different. It is an older, longer-lived star. Stars like ours are born in the arms but often leave them, continuing their orbit around the galaxy. Right now, our solar system is between arms, in a quieter region. We are not inside the main traffic jam, but on the open road between them. This traffic analogy explains why spiral arms appear stable, even though stars are constantly moving. Just as cars flow through a traffic jam, stars flow into and out of spiral arms. The arms remain visible because they are continually renewed by new arrivals and new bursts of star formation. Seen from above, the Milky Way would appear as a barred spiral, with a bright central bar of stars and several main arms branching outward. The arms are not rigid structures. They are flowing, shifting patterns, like ripples in water or sound waves in air. And yet, to our eyes, they give the galaxy its graceful, iconic form. Living inside one of these patterns, we see only a fragment. The hazy band of the Milky Way across the night sky is our inside view of a spiral arm, seen edge-on. We are passengers in the traffic jam, unable to step outside and see its true shape. But by mapping the positions of stars, by tracing the radio signals of hydrogen gas, astronomers have revealed the grander picture. The spiral arms are both real and not real collections of stars that glow more brightly because they are temporarily crowded together. They are patterns etched into the galaxy by gravity and motion, not solid bridges of light. It is a humbling thought. The most iconic feature of our galaxy, the thing we imagine when we think of the Milky Way, is not permanent, not solid, not fixed. It is a pattern, a ripple, a temporary wave moving through the stars. And yet, like traffic jams on a highway, it endures long enough for us to notice, to map, and to marvel at its beauty. Our solar system is not adrift in random emptiness. It resides within a structure, a protective hollow, known as the local bubble. This bubble stretches for about 1,000 light-years in every direction, a vast cavity carved into the interstellar medium. The local bubble exists because of violence. Millions of years ago, a cluster of massive stars lived and died in this region. Each ended its life in a supernova, exploding with unimaginable power, releasing more energy in seconds than our sun will produce in its entire lifetime. These blasts swept away gas and dust, carving out a hollow in the galaxy. Over time, multiple explosions overlapped, hollowing the region further, creating what astronomers call a superbubble. The walls of this bubble are made of thin, hot gas, still glowing faintly in X-rays from the energy of those ancient deaths. And inside that hollow, our solar system drifts. It is a strange kind of safety. The explosions that created the local bubble could have sterilized nearby worlds, ending any chance of life. Yet billions of years later, the result is a calmer, emptier space. Within this cavity, there are fewer dense clouds of gas to interfere with our Sunday. There are fewer sources of radiation that could threaten life. In a sense, we live inside the ghost of destruction, protected by the very violence that once swept this region clean. Astronomers can even see the edge of the bubble. In every direction, when we look far enough, the density of interstellar gas increases. The bubble has boundaries, thin walls marking the limit of the hollow. In a few million years, our solar system will drift out of this safe zone and into denser regions. What happens then remains a question. For now, the local bubble acts as a cosmic harbor. It shields us from some of the harsher conditions of the galaxy. It gives us a quieter neighborhood to evolve in, a chance for life to take hold. Without it, the story of Earth might have been very different. There is an irony in this. We often think of safety as peace, as absence of danger. But in this case, safety was created by destruction. The local bubble exists because stars died violently, scattering their matter and their energy into space. And from their ashes, a quiet hollow formed, a place where planets like Earth could circle their star without constant bombardment. When you look at the night sky, you are looking out through the bubble's edge. The stars you see shining in the distance are often beyond the boundary, glowing through the thin walls of this cosmic cavern. Our entire sky is shaped by the bubble we live in, even though we cannot see it directly. The local bubble is a reminder that we live not just on Earth, not just in the solar system, but within structures shaped by events long before us. Our neighborhood was carved by explosions, sculpted by forces beyond imagining, and gifted to us as a place where life could survive. Just beyond the edge of the local bubble lies one of the most spectacular regions in our galactic neighborhood, the Orion Molecular Cloud Complex. A vast nursery where new stars are born, it stretches for hundreds of light years, a cosmic factory for suns. To the naked eye, Orion is one of the most familiar constellations in the night sky. Its three-star belt, its bright shoulders and knees, are instantly recognizable, but hidden within its outline is something extraordinary. The Orion Nebula, visible as a faint smudge through binoculars, is a stellar nursery glowing with newborn stars. Inside these clouds, gravity works slowly but relentlessly. Vast amounts of gas and dust collapse inward, pulled tighter and tighter until pressure and heat ignite nuclear fusion. A star is born. It shines not by reflection but by its own light, releasing energy from the fusion of hydrogen into helium. Star birth is not gentle. The radiation and stellar winds from newborn suns carve bubbles and cavities in the surrounding gas, sculpting structures that look like pillars and waves. Some regions glow in vivid colors, illuminated by the energy of massive stars. Others remain dark, hiding stars still wrapped in their dusty cocoons. The Orion complex is so large that light itself takes years to cross it. Some will grow into giants, blazing bright and dying young. Others will be smaller, steady, and long-lived, like our Sunday. Around many of them, disks of dust and gas swirl, the raw material for planets. Even now, solar systems are taking shape in Orion, worlds that may one day host life. This is not just a local curiosity. The Orion Nebula and its surroundings give us a glimpse into our own past. 4.5 billion years ago, our sun was born in a similar nursery, surrounded by thousands of stellar siblings. Those siblings have long since drifted away, scattered across the Milky Way. But the process continues, generation after generation. When you look at Orion on a winter night, you are not just seeing stars. You are witnessing creation itself. You are seeing the places where the galaxy builds its future. The gas and dust in those clouds will one day become stars, planets, oceans, and perhaps even living beings. There is poetry in this. The atoms in your body, the oxygen you breathe, the calcium in your bones, the iron in your blood were all forged in stars. Those atoms were once inside massive suns that lived and died billions of years ago. Now, in Orion, the cycle continues. New stars are forming, new elements are being forged, new possibilities are being written. The Orion molecular cloud is a reminder that the Milky Way is alive, constantly renewing itself. Stars are not permanent fixtures. They are born, they shine, they die, and from their ashes, new stars arise. The galaxy is a place of constant creation, and Orion is one of its greatest workshops. Look up on a clear night, far from city lights, and you may see a few thousand stars. It feels like a vast number, filling the heavens with light, but this is only the faintest fraction of what surrounds us. The Milky Way contains an estimated 400 billion stars. Some are small, faint red dwarfs, barely visible even through telescopes. Others are massive blue giants, burning with a brilliance thousands of times greater than the sun. Most are somewhere in between, ordinary stars like ours, shining steadily for billions of years. The scale of this number is almost impossible to imagine. If you tried to count each star in the galaxy, saying one number every second, it would take more than 12,000 years. And by the time you finished, new stars would have been born and old ones would have died. The galaxy is not a static collection, but a living system in constant flux. Among these stars, some are clustered in tight groups. Others drift alone in the darkness. Some travel in pairs, orbiting each other in eternal dance. Some belong to massive families of stars, bound together by gravity. And each one, in its own way, contributes to the glow of the Milky Way. The stars we see with our eyes are the brightest, the nearest, the ones close enough to pierce the atmosphere and dazzle us. But beyond them lie layer upon layer of faint stars, invisible without telescopes. They form the structure of the spiral arms, the glowing haze of the galactic disk, the halo that extends far beyond the visible edge. And here is the humbling part. 400 billion is just one galaxy. The observable universe may contain 2 trillion galaxies, each with billions or trillions of stars. The number of stars in existence is beyond anything we can truly comprehend. But we do not need to count them to be moved by them. It is enough to know they are there, scattered like jewels across the night, each one a sun, each one a possible home for planets and stories we can only imagine. The countless stars remind us that the Milky Way is both grand and ordinary. Grand, because it contains more suns than we can ever know. Ordinary, because it is just one among billions of galaxies. And yet, for us, this is the galaxy that matters. This is our island in the cosmic ocean. Every star you see tonight belongs to it. Every spark of light is part of the same spiral system we call home. And you, too, are part of it, made of the same atoms, born of the same processes, living within the same great galaxy of stars. When we gaze at the stars, it is easy to imagine them as solitary lights, glowing alone in the darkness. For centuries, many believed that stars were simply points of light, distant and unreachable, with nothing else around them. But now we know better. Around many of those stars, planets orbit. Some are gas giants, some are rocky worlds, some are barren, some perhaps fertile. Astronomers estimate that the Milky Way may contain over 100 billion planets, perhaps more. That means that on average, almost every star you see in the night sky may have at least one planet circling it. Some may have entire families, like our solar system, with multiple worlds and dozens of moons. These planets come in incredible variety. Some are hot Jupiters, gas giants orbiting so close to their stars that their atmospheres boil away. Others are frozen giants, drifting far from their suns, cold and dark. Some are super-Earths, rocky worlds larger than ours, with thicker atmospheres and stronger gravity. Others are water worlds, their surfaces covered entirely by oceans deeper than any we can imagine. Among this diversity may lie Earth-like planets, rocky, temperate worlds with liquid water and atmospheres capable of sustaining life. The search for these planets has become one of the most exciting pursuits in astronomy. Telescopes now detect the subtle dimming of a star as a planet passes in front of it. They measure the faint tug of a planet's gravity as it pulls on its star. With these techniques, thousands of exoplanets have already been discovered, with many more waiting to be found. It is a humbling thought. When you look up at the Milky Way, many of those points of light are not just stars, but entire solar systems. Each one could host worlds as complex as our own. Each one could tell its own story of creation, evolution, and perhaps even life. Life itself is the great question. Are we alone, or are there other beings gazing back at us from distant worlds? The galaxy is vast enough that even if life is rare, there could still be millions of inhabited planets. Yet the distances are so immense that contact remains uncertain, perhaps impossible. For now, these hidden planets remain silent, their secrets locked away by light years of distance. But even if they are unreachable, their existence is profound. It means that Earth is not unique in having planets. It means that our solar system is not an anomaly, but a common pattern in the galaxy. It means that the Milky Way is filled not only with stars, but with countless worlds, each with its own landscapes, skies, and possibilities. The hidden planets remind us that the galaxy is richer than what we see. They tell us that for every star, there may be companions unseen, orbiting faithfully in the dark, and they invite us to imagine, to wonder what kinds of worlds might exist, what kinds of life might thrive, and what other stories might be unfolding under alien suns. Far beyond the thin disk of the Milky Way, in the halo that surrounds it, lie some of the oldest structures in the galaxy, globular clusters. These are dense spherical swarms of stars, bound tightly together by gravity, orbiting the Milky Way like ancient satellites. Each globular cluster contains hundreds of thousands, sometimes millions, of stars packed into a region only a few dozen light-years across. To live inside, one would be to live in perpetual twilight. The night sky would never be dark. Instead, it would blaze with the light of thousands of suns, each so close that you could read by starlight alone. The stars in globular clusters are ancient. Many formed more than 12 billion years ago, not long after the universe itself began. They are fossils of the early cosmos, still orbiting the Milky Way after eons, still glowing faintly with the light of hydrogen burning slowly in their cores. These clusters are not scattered evenly. They form a halo around the galaxy, orbiting far above and below the disk. From Earth, we can see them as fuzzy points in the sky, best revealed through telescopes. Each one is a miniature galaxy, a city of stars moving together in a gravitational dance. What makes them remarkable is their density. In our solar neighborhood, the nearest star is more than 4 light-years away. But in the heart of a globular cluster, stars can be separated by only a fraction of a light-year. Their gravitational interactions are constant, shaping orbits, stealing planets, and sometimes merging stars together. For astronomers, globular clusters are windows into the past. By studying their stars, scientists learn about the conditions of the early Milky Way. Their age, their chemical makeup, their motions all tell the story of how galaxies form and evolve. They are the elders of the galactic family, still circling silently while younger stars blaze in the spiral arms below. And yet, they are not just relics. They are vibrant systems in their own right. Stars within them live long, slow lives, some lasting far longer than the universe has existed so far. If life ever emerged around such stars, it might endure for unimaginable spans of time, in skies so crowded that the concept of night would never exist. The globular clusters remind us that the Milky Way is not only a flat disk, but a 3-dimensional structure. Above and below us, these ancient cities drift, orbiting endlessly, keeping watch over the galaxy they helped to build. To look at one is to look into eternity. 1 billion years means little to these clusters. They have outlived countless generations of stars, and they will continue to orbit long after the sun has faded away. They are monuments to the persistence of the cosmos. Reminders that while our lives are fleeting, the galaxy holds structures that endure for almost forever. Stars are not eternal. They are born, they live, and eventually they die. And scattered throughout the Milky Way are the remnants of those deaths, stellar corpses, each with their own strange beauty. The most common are white dwarfs. These are the remains of stars like our Sun, which once burned steadily for billions of years. When such stars run out of fuel, they swell into red giants, shedding their outer layers into space. What is left behind is the core, a hot, dense sphere, no larger than Earth, glowing faintly as it cools. White dwarfs no longer fuse atoms in their cores. They shine only with residual heat, slowly fading into darkness over trillions of years. More exotic are neutron stars. These form when massive stars die in supernova explosions. The core collapses so completely that protons and electrons merge into neutrons, creating an object only about 10 miles wide, yet more massive than the Sunday. A teaspoon of neutron star matter would weigh billions of tons. Some neutron stars spin rapidly, beaming radiation like cosmic lighthouses. These pulsars can rotate hundreds of times per second, their signals sweeping across space in precise rhythms. Rarest of all are black holes, born from the most massive stars. Their collapse is so complete that nothing can escape, not even light. They drift invisibly through the galaxy, detectable only through their gravity or when they consume matter from nearby companions. Together, these remnants are the ghosts of the Milky Way. They are the after-images of stars that once shone brightly, now transformed into strange exotic states. They remind us that even stars must die, and that their deaths are not endings but transformations. The elements forged in their hearts are scattered into space, enriching the galaxy, preparing the raw material for future generations of stars and planets. In a sense, we owe our existence to these stellar corpses. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all were created in stars that died long ago. Their remnants still drift through the Milky Way, quiet witnesses to the cycles of creation and destruction. The galaxy is not just a place of shining stars, it is also a graveyard, filled with white dwarfs cooling silently, neutron stars spinning endlessly, and black holes lurking unseen. And yet, from this graveyard, new life emerges. The ghosts of old stars seed the birth of new ones. Death becomes creation. Silence becomes renewal. When we look at the Milky Way, we see stars, gas, and dust. But what we see is only a fraction of what is truly there. Surrounding the galaxy is something vast and invisible, a halo of dark matter. Dark matter does not emit light. It does not absorb it. It does not interact with ordinary matter in any way we can detect except through gravity. We know it exists because of the way galaxies move. The stars in the outer regions of the Milky Way orbit far faster than they should if only visible matter were present. Something unseen must be adding gravity, holding everything together. That something is dark matter. Estimates suggest that dark matter makes up about 85% of the galaxy's total mass. The stars, planets, gas and dust, the things we can see, make up less than 15%. In other words, most of the Milky Way is invisible. The dark matter halo is enormous, extending well beyond the visible disk of the galaxy. While the disk is 100,000 light-years across, the halo may stretch several times farther, encompassing the entire galaxy in a sphere of unseen gravity. What is dark matter? That remains one of the greatest mysteries of science. It is not made of atoms. It is not made of anything we know. Perhaps it is composed of undiscovered particles, weakly interacting with the rest of the universe. Perhaps it is something stranger still, beyond our current understanding of physics. And yet, without it, the Milky Way could not exist. Without dark matter, the stars would not orbit as they do. The galaxy would not hold together. We ourselves would not be here. There is humility in this realization. The things we can see, stars, planets, even ourselves, are only a small fraction of reality. The vast majority of the galaxy is invisible, detectable only through its pull. The structure of the Milky Way, the existence of galaxies themselves, depends on something we cannot see and do not yet understand. The invisible halo is a reminder of how much we do not know. We live inside a galaxy whose true nature is still hidden. We see only its glowing surface, while most of its mass remains mysterious. And yet, there is beauty in the mystery. The fact that the universe holds secrets, that it challenges us to look deeper, that it humbles us with questions we cannot yet answer. The dark matter halo is the unseen foundation of the Milky Way. It is the silent framework that holds the galaxy together. It is the invisible stage upon which every star, every planet, every life form plays its part. In 1977, humanity launched 2 spacecraft, Voyager 1 and Voyager 2. Their mission was simple in concept yet daring in scope to explore the outer planets and then continue outward into interstellar space. For decades they have travelled, carrying with them golden records containing the sounds and images of Earth, messages to anyone who might one day find them. Voyager 1 is now the most distant human-made object, more than 14 billion miles from Earth. Voyager 2 trails not far behind. They have left the protective bubble of the solar wind, entering the interstellar medium, drifting among the sparse atoms that fill the space between stars. They are true pioneers, the first emissaries of humanity into the galaxy. And yet, for all their speed and distance, their journey across the Milky Way is almost futile. Voyager 1 travels at about 38,000 miles per hour. At that speed, it would take more than 70,000 years just to reach the nearest star. To cross the galaxy, 100,000 light-years wide, would take billions of years. By then, the sun will be gone, Earth will be unrecognizable, and humanity itself may have vanished or evolved beyond recognition. The Voyagers are eternal wanderers. They will never return. They will never reach another star system in any meaningful time. They are destined to drift endlessly, carrying their tiny golden messages into a galaxy too vast to notice them. And yet, there is something profoundly moving about this. For the first time, human beings have sent objects beyond our solar system. We have touched the edge of interstellar space. We have placed our signature into the cosmos. Even if no one ever finds them, the Voyagers are proof of our curiosity, our drive to explore, our need to reach beyond the horizon. Perhaps one day, far in the future, an alien civilization will stumble upon one of these tiny craft, drifting in the void. Perhaps they will listen to the greetings, the music, the sounds of Earth. Perhaps they will learn that once, long ago, a small species on a small planet sent out a message saying, "We were here." The Voyager's journey may be futile in distance, but it is not futile in meaning. They remind us of the scale of the galaxy, of the immensity of the challenge before us. And they remind us that even in the face of futility, we still reach outward. The Milky Way is too vast for Voyager to cross, but in sending them, we declared ourselves citizens of the galaxy. We acknowledged the immensity of space, and we chose to face it with wonder. The center of the Milky Way is one of the most fascinating regions in the galaxy. It is crowded with stars, threaded with magnetic fields, and dominated by a supermassive black hole. But for centuries, it was hidden from us. Why? Because of dust. The space between stars is not completely empty. It is filled with gas and dust, tiny grains of carbon, silicon, and ice, smaller than the width of a hair. Individually, they are insignificant, but spread across tens of thousands of light years, they form enormous clouds that block visible light. When we try to look toward the galactic center, the dust absorbs and scatters starlight, hiding the view. From Earth, the Milky Way appears as a glowing band across the sky, with its central bulge rising in summer like a luminous arch. It is as if we live in a city, but can never see its downtown because of a constant haze. For centuries, astronomers wondered what lay behind this veil. Was there a cluster of stars? Was it simply empty space? The truth remained hidden until the invention of new telescopes that could see beyond visible light. Infrared light, radio waves, and X-rays can pass through the dust that blocks ordinary vision. Using these wavelengths, astronomers have revealed an astonishing view of the galactic core. Dense clusters of stars crowd the region, gas clouds swirl, heated by radiation, and in the very center, stars orbit an invisible giant, Sagittarius A*, the black hole at the galaxy's heart. The dust is both a barrier and a gift. Without it, we might be exposed to the harsh radiation of the core. With it, we are shielded. And at the same time, it forces us to innovate, to look with new eyes, to develop ways of seeing the universe that go beyond our human senses. There is a poetic irony in this. The very dust that hides the galaxy's center is made of the same elements that form planets, and even life. The carbon in your body, the silicon in your bones, the oxygen you breathe, all were once locked in ancient dust grains. We are made of the very substance that conceals the Milky Way's heart. So when you look at the hazy stripe of the Milky Way overhead, remember this: much of what you see is hidden. Behind that dust lies a teeming city of stars, a bustling downtown of cosmic activity. We cannot see it directly, but we know it is there. And in its mystery, it continues to remind us that the universe always holds more than our eyes can reveal. If you could step outside the galaxy and look at it from afar, the Milky Way would not be a simple pinwheel of stars. It would be a barred spiral. That means that instead of its spiral arms beginning at a round core, they extend outward from a central bar of stars, stretching thousands of light years across. This bar is not obvious from our position within the galaxy. For centuries, we imagined the Milky Way as a simple spiral, with arms winding out from a luminous center. But careful observations, mapping the positions of stars and gas, revealed the truth. The core is elongated. It is shaped more like a bar than a circle, and the spiral arms extend from its ends. Why does this matter? Because the bar plays an important role in the life of the galaxy. It acts like a funnel, channeling gas toward the center. This flow of material feeds star formation near the core, and may even provide fuel for the supermassive black hole. The bar is not just a structure. It is a dynamic engine, driving the processes that shape the Milky Way. Bars are common in spiral galaxies. In fact, more than half of all spirals are barred. They appear to be a natural stage in galactic evolution, forming as stars and gas redistribute over billions of years. Some galaxies may lose their bars eventually. Others may develop new ones. The Milky Way's bar is simply one chapter in this ongoing story. From Earth, we cannot see the bar directly. But by mapping the motions of stars and the glow of hydrogen gas, astronomers have traced its outline. It stretches about 27,000 light-years, nearly a third of the galaxy's diameter. Within it, stars orbit in elongated paths, their collective gravity maintaining the bar's shape. The idea that our galaxy has a bar might seem like a small detail, but it changes how we picture our home. We do not live in a perfect pinwheel. We live in a structure shaped by dynamics, patterns, and flows. The Milky Way is not static. It is alive, shifting, evolving, sculpted by gravity into forms both beautiful and functional. When you imagine the Milky Way, picture not just a swirl of arms, but a bar at its core, glowing with billions of stars. Picture rivers of gas streaming along it, spiraling into the center, fueling the birth of new suns. Picture the bar as the backbone of the galaxy, holding it together, guiding its flow, shaping its destiny. We cannot step outside to see it, but we know it is there. And in knowing, we gain a clearer sense of the structure that cradles our existence. Every atom in your body has a history. The oxygen you breathe, the calcium in your bones, the iron in your blood, all were created in stars. This is the story of cosmic recycling, the process by which the galaxy continually remakes itself from the ashes of its dead. Stars are the forges of the universe. In their cores, hydrogen fuses into helium, releasing energy that makes them shine. Over time, heavier elements form carbon, oxygen, nitrogen, and more. But the heaviest elements, like iron and gold, require more violent processes. They are forged in supernovae, the explosive deaths of massive stars. When a star dies, it returns its material to the galaxy. A red giant sheds its outer layers, creating clouds of gas that drift into space. A supernova blasts its elements across light years, seeding the interstellar medium with the building blocks of future stars. Even neutron star collisions scatter rare elements, enriching the galaxy further. These remnants do not disappear. They mingle with gas and dust, forming molecular clouds. In time, gravity pulls these clouds together, creating new stars and new planets. The cycle begins again. Each generation of stars is enriched by the deaths of the ones before, containing more heavy elements, more possibilities for complex chemistry, more potential for life. Our Sun is part of this cycle. It was born from a cloud enriched by earlier generations of stars. Without them, Earth could not exist. The elements needed for oceans, for continents, for living organisms, all came from stars that lived and died long ago. This recycling shapes not only the galaxy's composition but also its appearance. Nebulas, glowing with colourful light, are the remains of dying stars. Dark molecular clouds are the birthplaces of new ones. The Milky Way is a system in constant renewal, never static, always evolving. There is comfort in this cycle. It means that nothing is wasted. Even in death, stars contribute to the creation of new life. Even in destruction, the galaxy builds anew. It is a reminder that endings are not absolute. They are transformations, steps in a larger rhythm that spans billions of years. When you look up at the stars, you are looking not just at light but at history. You are seeing the ongoing story of recycling, of matter being used and reused, of elements passing through countless forms before becoming part of you. You are a chapter in that story, and one day your atoms will return to the cosmos, continuing the cycle that has been unfolding since the beginning of time. Not every region of the Milky Way is equally suited for life. Some places are too chaotic, too dangerous. Others are too barren, lacking the elements needed for planets. But in between lies a region astronomers call the galactic habitable zone, a cosmic sweet spot where conditions may be just right. Closer to the galactic center, stars are packed tightly together. Radiation is intense. Supernovae erupt frequently. Planets there might struggle to maintain stable orbits, constantly perturbed by nearby stars. Farther out, in the sparse outer disk, the problem is different. Stars there are fewer, and they contain less of the heavy elements needed for planets and biology. Gas and dust are thin. Star formation is slower, and the conditions for life are less favorable. Between these extremes lies the habitable zone, not too crowded, not too barren. A region where stars have enough heavy elements to form rocky planets, but not so much chaos that those planets are constantly threatened. Our Sun sits comfortably within this zone, about halfway between the center and the edge of the galaxy. It is tempting to think of this as coincidence. But perhaps it is more than that. Perhaps life could only arise in such a balanced region. Perhaps the very fact that we exist means we must live in the habitable zone, because life elsewhere would have been far less likely to survive. The galactic habitable zone is not a sharp boundary. It is a range, a concept, a way of understanding where the ingredients for life are most abundant. And even within it, conditions vary. Some stars may have stable planetary systems, others may not. Some may have planets with water, atmospheres, and chemistry conducive to biology. Others may be barren rocks. Still, the idea that our place in the galaxy is not random but special is intriguing. It suggests that we are part of a larger pattern. It suggests that the conditions for life are rare and precious. Not scattered evenly, but concentrated in certain regions. When you look up at the Milky Way, imagine it not as uniform, but as layered. Imagine some regions too harsh, others too poor, and in between a band of possibility, where worlds like Earth may thrive. We live in that band. We are children of the habitable zone, products of a region where the galaxy has balanced danger and opportunity in just the right way. The space between stars is not empty. It is filled with invisible rivers of gas and dust, flowing through the galaxy like unseen streams. This interstellar medium is the raw material from which new stars and planets are made. Much of it is hydrogen, the most abundant element in the universe. Spread thin, it drifts between stars in diffuse clouds. In some regions, gravity and shock waves from supernovae compress it, creating denser clouds called molecular clouds. These are the birthplaces of stars, immense structures stretching for hundreds of light years, containing enough mass to form thousands of suns. These rivers of gas move and shift, shaped by gravity, by radiation, by the motion of stars and the spiral arms themselves. They are not static. They flow, they collide, they fragment. Where they overlap, new generations of stars flare into existence. We can see traces of these rivers in the Milky Way. Nebulas glowing red with hydrogen light. Dark lanes obscuring starlight, wisps illuminated by young hot stars. Each is a sign of the interstellar medium at work, creating and reshaping the galaxy. Our solar system itself was born from one of these clouds. Long ago, a river of gas collapsed, forming the sun and its planets. Even now, we drift through regions shaped by these flows, carried along by currents we cannot see. The interstellar medium is delicate, almost ghostly. In many places, its density is lower than the best vacuum we can create on Earth, and yet it holds the seeds of everything. Stars, planets, even life, all trace their origins to these rivers. Without them, the galaxy would be dark and barren, a collection of dying stars with no future. There is poetry in this hidden motion. Just as rivers on Earth carve valleys and nourish life, the rivers of gas in the Milky Way carve the structure of the galaxy and nourish its future. They are the unseen lifeblood of the cosmos, flowing silently, endlessly, weaving the galaxy into what it island. When you look at the Milky Way, know that behind its glow lies movement you cannot see. Rivers of gas flow between the stars, carrying the raw material for the next generation. And in those rivers, the future of the galaxy is already being written. The Milky Way may feel eternal, but it is not fixed. It is a moving, changing structure, part of a larger cosmic dance. And in that dance, one partner is drawing closer every day. The Andromeda Galaxy. Andromeda is the nearest large galaxy to ours, visible from Earth as a faint smudge in the constellation of the same name. It lies about 2.5 million light-years away, yet its gravity and ours are locked together. Slowly but surely, we are on a collision course. In about 4 billion years, the Milky Way and Andromeda will meet. Their stars will not crash into each other. Space is far too empty for that. But their gravity will tear at each other's shapes, distorting spiral arms, flinging stars into long tidal streams, and stirring up bursts of star formation. The two galaxies will swirl together in a chaotic embrace, their structures merging over hundreds of millions of years. Eventually, they will settle into a single galaxy larger, rounder, more massive. Astronomers call this future galaxy Milkomeda, or sometimes the Milk-Dromeda galaxy. It will not resemble the delicate spirals we know now, but an enormous elliptical cloud of stars, glowing with the combined light of two great systems. For Earth, the collision will be dramatic in the sky, but not catastrophic. By the time Andromeda looms overhead, the Sun will be nearing the end of its life, swelling into a red giant. Earth itself may already be uninhabitable. But for those who could witness it, the night sky will be transformed. Andromeda will grow larger and brighter, stretching across the heavens. Eventually, stars from two galaxies will mingle, and the view will become a dazzling chaos of light. Galactic collisions are common in the universe. We see them throughout the cosmos, pairs of galaxies distorted into strange shapes, their arms twisted, their centers glowing with bursts of new stars. The Milky Way's fate is simply part of this larger pattern. Galaxies grow by merging, by consuming each other, by blending into larger structures. There is a strange comfort in this. Even galaxies are not permanent. Even they are subject to change, to collision, to transformation. The Milky Way is our home. But it is also part of something larger, destined to merge and become something new. When you look up at Andromeda, faint though it may be, you are seeing the future. You are seeing the galaxy that will one day join ours, reshaping everything we know. In 4 billion years, the sky will blaze with its light. And long after we are gone, the Milky Way will live on not as it is now, but as part of something greater. Every star in the Milky Way is moving. Some race around the galaxy at hundreds of kilometers per second, Others drift more slowly, following elongated orbits that take them far from the disk. To the human eye, they seem fixed, steady points of light. But in truth, the night sky is a river of motion, stars gliding endlessly along invisible highways. Our Sun is one of these travelers. It orbits the galactic center every 230 million years, carrying Earth and the other planets along with it. Nearby stars share this motion, creating a kind of local flow, but over time, their paths diverge. Stars that were once neighbors drift apart, separated by billions of miles, lost into different currents of the galaxy. The Milky Way is like a vast highway system, with stars as cars traveling at different speeds and on different lanes. Some move in circular orbits, steady and predictable. Others swing out on elongated paths, plunging through the disk and soaring into the halo before returning again. Clusters of stars, like schools of fish, move together. Globular clusters orbit the galaxy in sweeping arcs. Open clusters drift apart more slowly, scattering into the disk. Streams of stars, remnants of smaller galaxies consumed by the Milky Way, trace ghostly trails across the sky. For astronomers, mapping these stellar highways reveals the hidden structure of the galaxy. By tracking the motions of millions of stars, they can see the shape of the Milky Way's gravitational field, the influence of dark matter, the history of past collisions. Each orbit tells a story, and together they form a record of the galaxy's past and future. On human timescales, these motions are imperceptible. Stars shift only by tiny amounts each century. But given millions of years, the constellations themselves will change. Orion's belt will bend. The Big Dipper will scatter. The familiar patterns of our sky will dissolve, replaced by new arrangements we cannot yet imagine. This constant motion reminds us that nothing in the galaxy is fixed. The stars we see tonight are passing through, their positions temporary, their paths endless. Our Sun is just one traveler among billions, carried along by gravity, bound to the same highways that stretch across the galaxy. And yet, within this motion lies order. The galaxy is not chaos, but harmony. Billions of stars, each following its own path, yet together forming the graceful spiral of the Milky Way. When you look at the night sky, you are looking not at a still picture, but at a living system in motion. You are seeing the travelers of the galaxy, each on a journey millions or billions of years in the making. And you are part of it too, carried along on the same stellar highways, a passenger in the endless flow of the Milky Way. Most stars are born in clusters. Some of these are modest, like the Pleiades, a few hundred stars bound loosely together. But others are far more extreme superstar clusters, where tens of thousands of stars ignite in close proximity, forming some of the most energetic regions in the galaxy. These clusters are young, only a few million years old. They are filled with massive stars, dozens of times larger than the Sun, burning so brightly that their combined light can outshine entire regions of the Milky Way. Their radiation and stellar winds carve vast cavities in the surrounding gas, creating bubbles and pillars, sculpting the interstellar medium into strange shapes. To live inside a superstar cluster would be to live under an extraordinary sky. Stars would fill the heavens, blazing so brightly that night would never truly come. But such beauty comes with danger. Massive stars live fast and die young. Within a few million years they explode as supernovae, blasting the cluster with radiation and shock waves, scattering heavy elements into space. Superstar clusters are thought to be the birthplaces of globular clusters if they survive long enough. Most, however, disperse over time. Gravity cannot hold them together once their gas is blown away by stellar winds and explosions. The stars drift apart, becoming part of the galaxy's disk. Yet for a brief time, these clusters are extraordinary. They are laboratories of star formation, places where the processes of creation and destruction unfold with stunning intensity. They are rare, but they shape the galaxy in profound ways, enriching their surroundings with elements, driving turbulence in the interstellar medium, and contributing to the grand cycle of matter. Our Sun was not born in such an extreme cluster, but in a more modest one. Still, it likely had dozens or hundreds of siblings, now scattered across the Milky Way. Somewhere among the stars may still exist. Those sibling stars born from the same cloud as the Sun, carrying the same chemical fingerprints. Finding them is like searching for family in a crowd of billions. The superstar clusters remind us of the galaxy's extremes. Not every region is calm or gentle. Some places are fierce, brilliant, short-lived. They burn with intensity, shaping the galaxy around them, then fade, their stars drifting into the wider disk. They are fireworks displays on a cosmic scale, brief, spectacular, and transformative. Einstein taught us that gravity and time are intertwined. The stronger the gravity, the slower time flows. And nowhere in the Milky Way is gravity stronger than near its center, close to the supermassive black hole Sagittarius A. Stars there orbit at incredible speeds, whipped around by gravity so intense that space itself is warped. To observers far away, time in this region appears to run more slowly. A clock placed near the black hole would tick more slowly than one here on Earth. For those near the core, life would proceed as normal. But to us, watching from afar, their seconds would stretch longer, their movements slowed by the weight of gravity itself. This effect is called time dilation, and it is not just theory. Astronomers have measured the orbits of stars near Sagittarius A, watching them move in ways that confirm Einstein's predictions. Their light is redshifted, stretched as it escapes the black hole's gravitational pull. Their orbits reveal the hidden structure of space and time at the galaxy's heart. The idea that time flows differently in different places is deeply unsettling, but also deeply beautiful. It means that the universe is not rigid. It is flexible, dynamic, shaped by mass and energy. It means that the Milky Way is not just a collection of stars, but a structure where time itself bends and curves. For us, far from the core, the effect is negligible. Time here flows steadily, unnoticeably influenced by the Sun and Earth's gravity. But near Sagittarius A, the difference is profound. Stars live and die in environments where time moves at a different pace. Their stories unfold in rhythms we cannot fully share. This is another reminder that we are not central. We are not privileged observers. We see the galaxy from our quiet suburb, but near its core, reality itself plays by different rules. To imagine standing there is to imagine a world where even the seconds of your life are stretched by forces beyond comprehension. Time slows near the core, but the galaxy continues its rhythm. Stars orbit, black holes wait, gas clouds swirl, all within the bending fabric of space-time. And from our distance, we watch, we measure, and we marvel at a truth that reminds us how strange and how wondrous the universe truly island. The Milky Way feels endless, but it does have an edge. Beyond a certain distance, the glowing disk of stars thins out, the spiral arms fade. The gas and dust diminish, and eventually the galaxy dissolves into darkness. The disk of the Milky Way stretches about 100,000 light-years across. Within this region, stars are concentrated into a flat plane, orbiting the galactic center in orderly paths. But as you move outward, the stars become fewer and fewer. Beyond the edge lies the galactic halo, a sparse region populated by scattered stars, globular clusters, and dark matter. It is a frontier, a transition between the ordered structure of the disk and the emptier space beyond. From here, the Milky Way fades into the larger cosmos, one galaxy among many in the local group. The edge of the disk is not sharp, like the rim of a coin. It is fuzzy, fading gradually, with stars becoming rarer until the background takes over. But for astronomers, measuring this boundary helps define the size of the Milky Way. It is the line between the galaxy's luminous heart and the wider universe. Standing metaphorically at this edge, imagine the view. Behind you, the galaxy stretches across the sky, a glowing disk filled with billions of stars. Ahead of you lies the dark void of intergalactic space. The nearest galaxies shimmer faintly, islands across a cosmic sea. The contrast is striking: the brightness of the Milky Way behind you, the emptiness of the universe before you. For us, here on Earth, the edge is unimaginably far away, tens of thousands of light years. No probe, no ship, no technology we have could ever reach it. But in our minds, we can travel there. We can imagine standing at the boundary, looking back, seeing our galaxy as a whole, and realizing how fragile it is in the vastness of space. The edge of the disk reminds us that the Milky Way, for all its immensity, is finite. It is an island, with boundaries, with limits. Beyond it lies the unknown, the infinite stretch of the universe. And yet, within those limits, it contains everything we know, every star, every planet, every story of life. The Milky Way is not a solitary giant. It has grown by consuming others. Over billions of years, smaller galaxies have drifted too close, captured by our gravity, pulled apart and absorbed. Their remnants still linger, stretched across the sky in faint streams of stars. These stellar streams are ghostly trails, long ribbons arcing across the halo of the galaxy. They are the shredded remains of dwarf galaxies and globular clusters, torn apart by tidal forces. To the eye, they are invisible. But to telescopes, they reveal themselves delicate threads of light weaving through the darkness. One of the most famous is the Sagittarius Stream, the remains of a dwarf galaxy that is currently being consumed by the Milky Way. Its stars stretch across the sky, wrapping around the galaxy in great loops. Other streams, like the GD1 or the Orphan Stream, trace similar paths, evidence of countless past collisions. These streams tell a story. The Milky Way is not static. It is a predator, a collector, a structure built from the remains of smaller galaxies. Each stream is a fossil, recording an encounter millions or billions of years ago. Piece by piece, the Milky Way has grown by devouring its neighbors. For astronomers, mapping these streams is like archaeology on a cosmic scale. By tracing their paths, they reconstruct the galaxy's history. They can see when a dwarf galaxy was captured, how it was torn apart, and how its stars now orbit as part of the Milky Way. But these streams are not just relics. They are also laboratories. By studying the way their stars move, astronomers learn about the distribution of dark matter. The streams act like paint thrown across an invisible surface, revealing the shape of the galaxy's gravitational field. To imagine standing within one of these streams is to imagine being surrounded by stars that once belonged to a different galaxy, now scattered across thousands of light years. Each star carries the memory of its former home, even as it now drifts in ours. The streams remind us that galaxies are not isolated. They interact, they collide, they consume. The Milky Way we live in is not the same galaxy that existed billions of years ago. It is a composite, built from many others, its identity woven from the remnants of its meals. When you look at the night sky, some of the stars you see may once have belonged to another galaxy. They are immigrants, absorbed into the Milky Way, now indistinguishable from native stars. Our galaxy is not pure. It is a mosaic, built from countless encounters, its streams flowing invisibly across the heavens. In the southern sky, visible to the naked eye, float two luminous patches of light. They are not clouds in Earth's atmosphere, but neighboring galaxies, the large and small Magellanic Clouds. These irregular dwarfs are companions of the Milky Way, bound to us by gravity, orbiting like satellites around a giant. The Large Magellanic Cloud, or LMC, lies about 160,000 light-years away. It is home to about 30 billion stars, including the Tarantula Nebula, one of the most active star-forming regions known. The Small Magellanic Cloud, or SMC, is farther still, with about 3 billion stars. Both are dwarfed by the Milky Way, yet they glow brightly in the southern sky, reminders that our galaxy is not alone. These clouds are not just companions, they are participants in a dynamic relationship. Their gravity pulls on the Milky Way, and ours pulls on them. Streams of gas connect the galaxies, drawn out by tidal forces, creating the Magellanic Stream, a river of hydrogen stretching across the sky. Eventually, the clouds may be absorbed entirely. Already, evidence suggests they are being torn apart, their stars and gas captured by the Milky Way. Like other dwarfs before them, they may one day vanish as distinct galaxies, their matter scattered into our own disk and halo. For now, they are spectacular to behold. In dark skies far from city lights, they appear as soft glows, patches of brightness that look like small galaxies because they are small galaxies. To ancient navigators in the southern hemisphere, they were guides, fixed beacons in the sky. To astronomers today, they are laboratories, places to study star formation and galactic interaction up close. The Magellanic Clouds remind us that galaxies do not live in isolation. The Milky Way is part of a family, surrounded by dozens of dwarf galaxies, some faint and hidden, others shining bright. These companions orbit, interact, and eventually merge, contributing to the ongoing growth of the Milky Way. When you look at the Magellanic Clouds, you are seeing both the present and the future. You are seeing galaxies in their own right, rich with stars and nebulae. And you are seeing the future ingredients of the Milky Way, matter that will one day join our galaxy, enriching its mass, shaping its evolution. They are reminders that even galaxies are not eternal individuals. They are communities, families, groups, bound together, changing each other, and sometimes becoming one. The Milky Way is not alone in the cosmos. It belongs to a community of galaxies known as the local group, a small cluster bound together by gravity, drifting through space as one. The local group contains more than 50 galaxies. The largest are Andromeda, the Milky Way, and the Triangulum Galaxy. Surrounding them are dozens of smaller dwarfs, faint companions that orbit the giants or float between them. Together, they span about 10 million light-years, a tiny corner of the universe yet vast beyond comprehension. Andromeda is the largest, slightly bigger than the Milky Way. It dominates the group's future, drawing us slowly into its orbit, ensuring the eventual merger of our galaxies. Triangulum is smaller but still significant, perhaps orbiting Andromeda itself. The Milky Way is the second largest member, massive and bright, with its own collection of dwarf satellites. The local group is like a family, each galaxy influencing the others. The dwarfs are the youngest siblings, vulnerable to being consumed. The giants are the parents, shaping the structure of the group. Streams of stars and gas connect them, evidence of interactions already underway. Beyond the local group lie larger structures, galaxy clusters, and superclusters. Compared to those, our group is modest, a small gathering in a universe of vast assemblies. But for us, it is home. Every star you see belongs to the Milky Way, and every galaxy visible to the naked eye belongs to the local group. For astronomers, the local group is a laboratory for understanding how galaxies live together. By studying its members, we learn about mergers, star formation, and the role of dark matter. By mapping their motions, we glimpse the larger flow of the universe. The local group reminds us that even galaxies are not solitary. They are social, bound by gravity into families, each with their own histories and destinies. Our galaxy is not just a lone island, but part of a small archipelago, drifting together in the cosmic sea. The Milky Way, magnificent as it is not innocent. It has grown by cannibalism, devouring smaller galaxies that drift too close. This process, violent yet creative, is written into the very structure of our galaxy. We see the evidence in streams of stars, trails left behind, as dwarf galaxies are torn apart. We see it in the distorted motions of clusters, their orbits betraying past mergers. We see it in the chemical fingerprints of stars, some enriched in ways that suggest they were not born here, but imported from other systems. One of the most striking examples is the Sagittarius dwarf galaxy, currently being consumed. Its stars are stretched into long arcs around the Milky Way, slowly dissolving into our disk. Other dwarfs, long gone, have left their stars scattered, indistinguishable from native ones. Piece by piece, the Milky Way has grown by consuming its neighbours. This cannibalism is not unusual. It is how galaxies grow. In the universe, larger galaxies absorb smaller ones, merging their stars, gas, and dark matter. Sometimes the process is gentle, sometimes violent. But always, the result is growth. Without it, the Milky Way would be far smaller, far less grand. Even globular clusters may be remnants of past galaxies, their dense cores surviving long after their outer stars were stripped away. The Milky Way is a mosaic of these remnants, a tapestry woven from countless meals over billions of years. It is strange to think that the galaxy we call home is built from destruction. The mergers stir up gas, triggering starbursts. They enrich the interstellar medium with new material. They add diversity to the population of stars. Our own sun may trace its ancestry to such events, born from gas enriched by stars that once belonged to another galaxy. We are, in a sense, children of cannibalism, products of the Milky Way's appetite. When you look at the Milky Way, you are seeing not a pristine structure but a survivor of countless mergers. Its arms, its halo, its streams all tell the story of galaxies consumed, their stars now part of our own. The Milky Way is beautiful not because it is untouched, but because it is complex, shaped by history, built from the lives of others. How do you measure something you cannot see? The Milky Way is too vast to step outside and look at directly. Yet astronomers have developed clever methods to chart its size and structure. Among the most important are standard candles, objects whose brightness is known. One kind of standard candle is the Cepheid variable. These stars pulse in regular rhythms, their brightness rising and falling in cycles. The length of the cycle tells astronomers their true luminosity. By comparing how bright they appear from Earth with how bright they really are, their distance can be calculated. Cepheids are like lighthouses scattered across the galaxy. By measuring them, astronomers map the spiral arms, the core, and the outer disk. They give the Milky Way its scale, turning the haze of stars into a measurable structure. Another type of candle is the RR Lyrae star, fainter but older, found in globular clusters. These stars help trace the halo and measure the galaxy's outer boundaries. Even supernovae, though rare, serve as candles, their brilliance visible across vast distances, calibrating our maps of nearby galaxies. Using these candles, astronomers have pieced together the size of the Milky Way about 100,000 light-years across. They have revealed its barred spiral shape, its arms, its bulge, its halo. Without them, the galaxy would remain a mystery, a blur of light with no dimensions. The concept is simple but profound. If you know how bright something should be, you can measure how far away it island. It is like holding a candle at arm's length. If it looks dimmer than expected, you know it must be farther. Multiply this method across billions of stars, and the galaxy takes shape. There is elegance in this approach. With nothing but light, timing, and careful measurement, humans have mapped structures tens of thousands of light-years away. We have measured the immeasurable, turned the invisible into something knowable. When you look at the night sky, remember that some of those stars are more than just points of light. They are markers, candles in the dark, guides that have allowed us to chart the vastness of the Milky Way. When we imagine the Milky Way, we often picture a flat, elegant disk, like a cosmic vinyl record spinning silently in space. But reality is more complex. The Milky Way's disk is warped, twisted like a bent plate, its edges curling upward on one side and downward on the other. This warp was discovered by mapping hydrogen gas across the galaxy. Radio telescopes revealed that the outer regions of the disk are not aligned with the inner ones. Instead, they bend, as though the galaxy has been tugged or twisted. The stars follow this pattern too, tilted slightly in response to the warp. Why is the disk warped? Astronomers suspect several causes. One is the pull of the Milky Way's satellites, like the Magellanic Clouds. Their gravity may be tugging at the outer disk, distorting it. Another is the influence of dark matter, whose halo surrounds the galaxy. If that halo is lopsided, it could tilt the disk, warping it over time. The warp is not static. It seems to ripple, like a wave frozen in motion. This suggests that the Milky Way is still responding to interactions, adjusting to the pushes and pulls of its neighbours. The galaxy is not a rigid structure, but a living one, constantly shaped by forces both seen and unseen. From Earth, we do not notice the warp directly. The Milky Way still appears as a band across the sky. But if we could step outside and see it in full, the distortion would be clear. The edges would tilt, giving the disk a graceful, undulating form. There is something poetic in this imperfection. The galaxy is not perfectly flat, not perfectly symmetrical. It is bent, warped, shaped by its history and environment. And yet, in that warp lies beauty, evidence of the galaxy's interactions, its growth, its life as part of a larger cosmic web. When you look at the Milky Way, remember that what seems smooth is actually rippled, that beneath the calm appearance lies a story of tugs and pulls, of satellites and dark matter, of gravity bending the very shape of the galaxy. The warp is a reminder that even on the largest scales, the universe is dynamic, never truly still. You are moving faster than you can imagine. Right now, as you sit still, the Earth spins at about 1,000 miles per hour at the equator. The Earth orbits the Sun at about 67,000 miles per hour. But beyond these motions lies another, even greater one. The Sun's orbit around the Milky Way. Our Sun, with all its planets, moons and comets, races around the galactic center at about 514,000 miles per hour. That is nearly 140 miles every second. At that speed, you could circle Earth in less than 5 minutes. And yet, even moving so fast, it takes the Sun 230 million years to complete a single orbit of the galaxy. We do not feel this motion. The Sun carries us smoothly, steadily, along its path. The constellations appear fixed because their relative motions are so slow on human timescales. But in truth, the entire solar system is a passenger on this galactic journey, racing endlessly through space. Astronomers measure this speed by observing the Doppler shift of stars and gas, by mapping the motions of objects around the galactic center, by modeling the gravitational pull of the Milky Way. The result is astonishing. Our home star is a bullet of light, hurtling through the galaxy, bound only by gravity to its endless orbit. The speed of the Sun changes how we see ourselves. We are not stationary observers. We are travelers, carried along in a grand circuit that has repeated only 20 times since Earth formed. The dinosaurs never knew the Sun in this position. The continents were joined the last time Earth was here. The galaxy's journey is a timeline far greater than ours. And yet, this speed is what makes stability possible. The Sun's orbit is steady, nearly circular, keeping Earth at a safe distance from the chaos of the galactic center. We ride on a path that balances speed and gravity, ensuring that for billions of years, our solar system has been sheltered, undisturbed, allowed to nurture life. When you think of speed, think not only of cars or planes or rockets, but of the Sun itself, carrying us at 500,000 miles per hour. Think of the stars around us, each racing on its own orbit. The Milky Way is not still. It is alive with motion, and we are part of its flow. Distances in the galaxy are so vast that our ordinary measures, miles, kilometers, become meaningless. Instead, we use light years. The distance light travels in a year, nearly 6 trillion miles. Even so, the numbers strain our imagination. The nearest star system, Alpha Centauri, is about 4 light-years away. That means its light takes 4 years to reach us. When you look at it, you are seeing it not as it is now, but as it was 4 years ago. For stars farther away, the effect is greater. A star, 1,000 light-years distant, shines with light that began its journey before the rise of Rome. A star, 10,000 light-years away, glows with light older than recorded history. The Milky Way itself is about 100,000 light-years across. To cross it, light would take 100 millennia. Imagine walking 1 step per year. Each step is a light-year. 4 steps to Alpha Centauri. 100 steps to reach the Pleiades. Thousands of steps to the galactic core, and to walk across the galaxy. 100,000 steps, 100,000 years. On human scales, light years are incomprehensible. Yet they are the only way to make sense of the galaxy. They remind us that space is not just vast, but profoundly vast. That even the nearest neighbours are unimaginably far. That our solar system is a tiny bubble in an ocean so wide we cannot hope to cross it. And yet, in another sense, light years bring the galaxy closer. They let us imagine the journey as steps, as time, as something human. They turn the incomprehensible into something we can picture, even if only faintly. When you look at the stars, remember that you are looking back in time. Every star is a memory, its light a message that has traveled for years, centuries or millennia to reach you. The galaxy is not just a place, but a record of its own history, written in light. When we look up at the night sky, it feels like a dome, a perfect sphere surrounding us, dotted with stars like jewels on velvet. For most of human history, that is what we believed, that the stars were fixed on a celestial sphere, eternal and unmoving. But this is an illusion. The stars are not equidistant. They are scattered across the galaxy at different depths, some near, some far, some unimaginably distant. Constellations are tricks of perspective, patterns formed only because we view the stars from Earth. From another point in the galaxy, Orion's belt would not form a line. The Big Dipper would not look like a dipper. They are accidents of viewpoint, not true shapes in space. Even their brightness is deceptive. A star may appear bright because it is close, not because it is powerful. Another may blaze with thousands of times the sun's energy, but lie so far away that it looks faint. The night sky is not a map of true distances or powers, but a projection, a shadow of the galaxy's complexity. Over time, this illusion changes. Stars move, slowly, imperceptibly. Constellations shift. The North Star was not always Polaris, and will not always be. The sky is a living, changing scene, though we cannot see its motion within a single lifetime. The illusion is beautiful. It gives us patterns to follow, stories to tell, guides to navigate. Cultures across the world have seen animals, heroes, gods, and spirits in the stars. The night sky is not just an illusion of perspective. It is a canvas for human imagination, linking us to the galaxy through myth and meaning. Yet science reveals the deeper truth. The dome is an illusion. The constellations are accidents. The stars are not fixed, but drifting rivers of light. The galaxy is not a sphere above us, but a vast disk we inhabit, its stars stretching tens of thousands of light years in all directions. When you look up tonight, see both truths. See the constellations, the patterns, the myths, and also see the illusion for what it is, a perspective from one small planet, looking outward into a galaxy too vast to comprehend. After all the numbers, the scales, the distances, what does it mean? What does it mean to live inside a galaxy 100,000 light-years wide, with 400 billion stars, surrounded by dark matter, destined to collide with Andromeda, drifting in a universe of trillions of galaxies? It means perspective. It means humility. It means wonder. We are small, so small that even our entire planet is less than a speck compared to the galaxy. Our lives are brief, so brief that even the history of civilization is less than an instant compared to a galactic year. And yet, we are here. We are conscious. We can look up, ask questions, imagine scales far beyond our reach. We are made of the galaxy. The atoms in our bodies were forged in stars, recycled through supernovae, carried in clouds of gas, shaped into planets, and eventually into life. We are not separate from the Milky Way. We are its children, its products, its reflections. Our place in the vastness is not central, but it is meaningful. We are not at the core, but in a quiet arm. We are not among the most massive stars, but orbit a modest one. We are not unique in being planetary, but we are unique in being aware. Awareness is our gift, our rarity, our contribution to the galaxy's story. The Milky Way is vast, but it is also home. It cradles us, carries us, shapes us. We may never cross it. We may never leave it. But we belong to it, and that belonging is enough. When you close your eyes tonight, remember that you are part of something immense. That you are drifting through the galaxy at 500,000 miles per hour. That above you, billions of stars shine, each one a sun, each one a possibility. That the Milky Way surrounds you, holds you, and includes you. Our place in the vastness is small, but it is real, and in its immensity, there is peace. And so, our journey across the Milky Way draws to a close. We began in our own small corner, the quiet Orion arm, and followed the Sun on its 500,000-mile-per-hour orbit around the galaxy. We traced the elegant spiral arms, the hidden rivers of gas, the ancient globular clusters, and the ghosts of stars long gone. We peered into the crowded heart of the galaxy, where time itself bends under the pull of a supermassive black hole. We travelled outward to the Magellanic Clouds and the local group, and even glimpsed the far future, when the Milky Way will merge with Andromeda to form something new. What we found, again and again, is perspective. The Milky Way is vast beyond measure, 100,000 light-years across. 400 billion stars strong, with most of its mass hidden in a halo of dark matter. And yet, in all that immensity, we discovered that our small place is not meaningless. We are part of the galaxy's story. We are its children, born of recycled stardust carried in its orbit shaped by its history. Every breath you take, every heartbeat, happens while travelling through this cosmic structure, bound to it by gravity, connected to it by origin. To live here is a gift, to know of it is a wonder, and to rest beneath its stars is a privilege beyond words. So, tonight, as you drift toward sleep, allow yourself to feel that gratitude. Gratitude for being alive, for belonging to this incredible galaxy, for having the chance to look up and wonder. The Milky Way will continue its journey, slow and steady, carrying you gently through the vastness. All you need to do is rest, breathe, and dream. Good night, traveller of the Milky Way.